Hello, Tomorrow. I've got a serious question for you. Do you think Pluto should be a planet? Well, we're here today to chat with Dr. Kirby Runyon from the Johns Hopkins APL, and today we are going to discuss what the science actually says.
And then we're going to have a look at questions and comments from you, the community of tomorrow. Will your question be featured? Stick around to find out. This is Tomorrow's Science Discovery 1.12. And thanks for sticking with us. So we're going to get straight into our interview today. Kirby, thank you so much for taking the time to fly out here and join us.
My pleasure. Thanks so much for having me. It's great to be here.
Really excited to talk about all things Pluto. I think Pluto is amazing. I think it should be a planet. That's what we're here to discuss today. We're going to talk about the science, and we're going to talk about what New Horizons actually tells us about what's going on at Pluto. So you're actually a planetary geologist with a PhD, is
That's
that correct?
right, yeah. I finished my PhD a few years ago from Johns Hopkins University in planetary geology.
Congratulations.
So, thank you. Space rocks. That's planetary geology.
That's kind of rocks.
Yeah, so I study landscape evolution on planets, moons, and asteroids throughout the solar system, and most of the way I do that is from images sent back to Earth from robotic spacecraft that NASA and international space agencies have launched around the solar system in the pointy end of rockets.
Wow, are you actually working on the images that have come from like the furthest reaches of the solar system? Like, would you say that your work is looking at the deepest images of our solar system we've ever sent
Yes.
back?
So the furthest picture ever taken from space was probably when Voyager 1 took a picture of Earth from, gosh, 3 or 4 billion miles away.
Yes,
the
exactly.
pale blue dot.
In between the rings of Saturn, if I'm not mistaken.
Oh, that was Cassini, actually.
That was Cassini,
did
sorry.
another pale blue dot. No, that's cool. I mean,
You know, it's all great photos.
It's a blue pixel either way.
It's a dot.
It's a dot. But yeah, actually, New Horizons is flying past Ultima Thule, which is a 30-kilometer wide icy asteroid, depending on the time zone, either New Year's Eve or New Year's Day in 1 month, like literally a month from today. And when that happens, Ultima Thule will be the furthest explored world in the solar system ever. And those images will start coming back the same day.
Wow.
And so I'll be doing, along with my team members on the New Horizons team, doing geology with those pictures that come back.
But why are we sending spacecraft so far out? Like, it's so far away from us, right? It's almost like you can't touch it, you can't really visualize what's out there. So why do we go so far and explore these deep reaches of the solar system?
It's all about further, faster, higher. All about just pushing the envelope, seeing what's out there. It's why we have the Tomorrow Show, is to explore space. I want to see what's out there. This is Captain Kirk or Captain Picard style exploration.
Absolutely.
Where you're going where no spacecraft has gone before, seeing strange new worlds.
Yeah, and that's like, I love that gung-ho attitude about it, because a lot of times people ask, we're pouring so much money into it, but why? And I guess that leads into my next question. What can studying these other planets, especially these really distant bodies, what can that teach us about our own?
It helps us in a field called comparative planetology,
Ooh.
where you learn about one planet, and then that tells you things that are similar and different to other planets. For example, here on Earth we have sand dunes. There's sand that gets blown with the wind. Well, Pluto, with an atmosphere, I think it's 1/10,000th the density of our atmosphere, also has sand dunes. And no one ever expected that you could get air that thin to actually like blow the rough equivalent of sand, methane and nitrogen ice, on Pluto. And so it helps us, I don't know, understand our place in space. It improves the intangibles of life, our life satisfaction by knowing what's out there. At least it does for me. And I think that's worth spending $2 billion a year on NASA's planetary science budget.
I mean, you don't got to convince us.
Good.
Yeah, if I had $2 billion, I would send another New Horizons out because, like you said, we're learning these things about sand dunes that you would have never, ever expected to see on a different planet.
You could
like
do
that.
2 New Horizons for $2 billion.
Oh my goodness.
Ooh.
We have a question.
Newer.
We have a question
Newer,
here from the
newest.
chat room from Hanny's Warweb on Twitch. You were talking about the different geology on Pluto that we've discovered, and they want to know, is geology different for planets with icy features, like ice mountains, and how do you figure these things out from so far away?
Yeah, that's a great question. So the mountains on Pluto, we are confident they're made out of just regular frozen water, aka ice. And we're confident that it's not some other ice like nitrogen ice or methane ice because of how strong it has to be to support its weight.
Exactly.
So now, Lisa, there is an instrument on New Horizons called LISA that is
It's my favorite instrument.
it's an imaging spectrometer, and it can tell what things are made out of by the reflected sunlight. And we know that there's water ice from the spectra coming from LISA. Thank you so much. And also, because of how tall they are, in order to support their weight, if they were made out of like frozen methane or frozen nitrogen, they would collapse or sag under their weight. But water ice water ice at those distances from the sun is strong enough to support 10 to 20,000 foot mountains.
That is so epic.
Yeah.
Is that because of the molecular structure of water?
I think it has to. I think it has to do with the crystalline structure, so more than molecular.
yeah.
But yeah,
My bad.
but,
Yeah,
but
yeah.
close. Yeah.
Wow. Oh, man. We've got a couple more questions in the chat room here, too. Wicked wants to know, the sand dunes that you talked about on Pluto, how do you know that they're sand dunes and not hills?
Well, I guess you could say that a sand dune is a type of hill. We know that they're hills, but their morphology, their shape, when you look at them, is exactly the same as a type of sand dune on Earth called transverse dunes. We also see these on Venus, Mars, and Titan. We see transverse sand dunes. And they're the exact same morphology. They're shaped the same way, and they're oriented in the direction you would expect winds to be blowing. So there's this mountain range called the Aladrisi mountain range, just to the northwest of these sand dunes on Pluto. And there's a type of wind called a katabatic wind. It's when you have dense air at night, and it's like an air avalanche, and it flows downhill off those mountains, and it's exactly 90 degrees to the way that the dunes are oriented. And also, there are these cool things with a fun name called a nunatak. There are these.
Nunatak?
Nunatak. It's an Inuit word. It
sounds like it.
It's an island surrounded by ice instead of water. But you have these water ice mountains sticking up amongst this nitrogen ice glacier, and there are these wind streaks in the downwind part of it that are aligned the same direction as the sand dunes are.
Oh my goodness.
So based on all of that, we're confident that they're sand dunes. I guess you could call them snowdrifts, but same thing. Basically.
Semantics.
Yeah. Well.
And actually, this is a good question from the chat once more. Hanny's Vorwerp from Twitch actually asks, would geology on Pluto be affected by its elongated orbit? Like, would the mountains melt at perigee?
That's a great question. And so Pluto's distance from the sun varies by 20 times the Earth-Sun distance, 20 astronomical units. It goes from 30 to 50 AU, astronomical units. And 1 AU is about 150 million kilometers. So right now, Pluto's actually at roughly perihelion, its closest approach to the sun, which is still 30 AU, or 3 billion miles. So no, it's not going to melt. It never gets warmer than probably 50 Kelvin, 50 degrees above absolute zero.
Yeah.
That's cold.
But as it moves further from the sun, the atmosphere doesn't completely freeze out, but a lot of it will snow out onto the surface as nitrogen snow.
Okay.
And then as it warms back up, some of that nitrogen snow would sublimate, turn directly into a gas, and would shrink some of the landforms. So Sputnik Planitia is this nitrogen ice glacier. You've seen the famous heart on Pluto?
Yes.
The left ventricle of the heart is this nitrogen ice glacier. And that we think that grows and shrinks with Pluto's seasons, controlled by Pluto's distance from the sun.
Interesting. And then going back to all of these amazing epic discoveries we've made on the surface of Pluto, was there anything new that scientists discovered that, oh my gosh, we've never seen anything like this before, and we didn't even know this type of thing could exist? Was there any data like that?
Oh, sure, yeah. Couple examples are the stuff called washboard terrain. There's a paper just published by my colleague Oliver White, who's at NASA Ames Research Center, for a new type of glaciation that's been discovered on Pluto and nowhere else. Earth and Mars are the only planets where we've really seen glaciation, and Pluto's another planet where there's also glaciation happening.
Nice.
And but some of the washboard terrain, it's in a place off kind of the east side of the right ventricle of Pluto's heart called Tartarus Dorsa. And it's these huge blades of methane ice sticking up into the sky. And we think they are a type of ice landform called penitentes, which is a Spanish word, and I guess it roughly translates as like spike of ice.
Ouch.
That's
Yes.
amazing.
Yeah. And
Impaler.
and
wow.
So when I've been in Argentina in the high Andes Plateau in a very Mars-like terrain, I've seen penitentes, and they are these sheets of ice with spikes that point towards the sun.
Oh my goodness.
And it's from preferential sublimation, where the sun will sublimate, turn directly into water vapor, the ice surrounding it, and you end up with these spikes of ice that's related to the latitude you're at. So at the equator, they'd be pointing straight up.
Okay.
As you move away from the equator, they start to tip
Yeah.
over. And so there's a limit. So if you're past, like, I don't know, 28, 29 degrees north or south, you don't get penitentes because they'd fall over.
Oh my gosh.
Oh, wow.
And
So
they,
it's like-
yeah, and they only form in high altitude equatorial regions where you can have snowfall.
So interesting.
Yeah. And we
my
think Pluto
goodness.
has, like, so on Earth, these are like a few meters tall.
Yeah.
A few tens of feet at most. On Pluto, they're like kilometers tall.
Towering.
Yeah. I mean, and made out of methane and not water ice.
I mean, talk about, I'm just going to say this. We have like the 7 wonders of the Earth or whatever. I can't wait till we start naming the wonders of other bodies out there because it sounds like Pluto pretty much already has like a dozen that could be considered wonders.
Pluto's super weird.
It's so weird in the best way possible.
In the best way. Keep it weird, Pluto.
Oh yeah, keep it weird.
To link directly into that, there's a question here from Tawicked in the chat room who asks, you're given the opportunity to decide the location of the first Pluto lander/rover combo. Where would you put it and why?
How far can you drive? If it's a rover, how far can you drive?
Let's just say it's like nuclear
Okay.
powered with like an RTG because,
Right.
you know.
Because
this-
cold.
Yeah, yeah. So it's going to heat
Yeah,
it
so
and, yeah.
typically from a geologic sense, you want to go where the most geologic units come together in one spot. And that was the strategy taken by the Mars rover Curiosity. Right when it landed, there were 3 geologic units, different types of rock formations that formed in different ways. And so the rover went there first because it could explore, get a lot of variety in a short area. Oh my goodness. So I would probably send a Pluto rover with a limited roving distance, probably where Cthulhu Regio, which is this dark equatorial band.
It sounds
Around
dark.
the
That
planet.
name is
Ooh.
like
Come on,
mysterious
Yeah.
villain name.
Yes, yes.
Wow.
Where Cthulhu Regio meets some of the mountains close to the Aladrisia Mountains, which is also really close to Sputnik Planitia, which is also close to some of the cratered highlands. There's kind of these areas right in there where they all kind of come together. And I think you could get the most geologic diversity in a place like that. Now, having said that, we don't know what a lot of Pluto looks like because, you know, as the spacecraft New Horizons flew past Pluto, you know, we didn't get to orbit. We only saw one hemisphere of Pluto close up. And Pluto spins once every 6 days. So as the New Horizons spacecraft was on approach to Pluto, we saw the far side of Pluto, but only from a really long ways away, so it's blurry. Also, a lot of the southern hemisphere was in like quasi-permanent seasonal winter darkness. So we just have no idea what it looks like at all.
Oh my gosh.
So given what we know, that's where I would send the rover. But if we ever got a Pluto orbiter, we could map the entire planet, and then we can make a more informed decision where we could go.
You've convinced me. I definitely want a Pluto orbiter now. I don't know about you guys. If you think we should go to Pluto, leave a comment. But I think that would be cool.
I agree.
We need, what, $2 billion to send one out
Oh man,
there?
a rover, that's hard because
Yeah.
with New Horizons, you didn't have to slow down.
Yeah,
we were
that's
just
fair.
trucking by, I don't know, something like 12 kilometers per second, didn't have to slow down.
Pretty darn fast.
Yeah, you got to slow down a lot to land, and that's rocket fuel, and that's a rocket stage, and that's really heavy.
If we had like a BFR online, though, would that make it possible to have these extended Pluto missions?
A BFR would be very enabling, yeah. A BFR is a little bit more powerful than a Saturn V, and so especially if you could do in-space refueling with the BFR, then you could cheat the rocket equation, and you could do things like Pluto landers. And anything's possible with more money. You know,
There you
you know,
go.
space is not spelled with an S at the beginning. Space is actually spelled with a $sign at the beginning.
You're not wrong there.
So,
Very cool. So yeah, going back into the chat, there's a couple of interesting questions. So you mentioned Ultima Thule, and that's how you pronounce
Ultima
it?
Thule.
Thule, sorry.
Ultima Thule.
Thule, I said it the plebeian
H is
way.
silent.
I apologize. Thule. Zweeby in the chat asks, how comparable will be the scientific observations done of Ultima Thule to that of Pluto?
okay, so we're going to be coming 3 times closer. The New Horizons spacecraft will come 3 times closer to Ultima Thule than we did to Pluto. That being said, Pluto is well over 1,000 kilometers in diameter. Ultima Thule is 30. So it's small. It's about the same size as Saturn's small kind of moonlets that
Got
orbit
it.
close, like Pan and Atlas, those little tiny Saturnian moons that kind of orbit near the rings. Ultima Thule is about the same size, 30 kilometers. It's a 30-kilometer size, basically icy asteroid. We call them Kuiper Belt objects. I think the highest resolution we'll get is a few hundred meters per pixel. So you know, you can see big regions. We're not going to see things as close up as we did on Pluto. At Pluto, the highest resolution we got was 79 meters per pixel. We're not going to quite get that much with Ultima Thule, but it will be better than anything else ever seen out there. So
Absolutely.
Is there a way that, like, the public, like, say our people at home, the community, people watching this on demand, if they want to, like, obviously you're not going to get a live stream from New Horizons approaching Ultima Thule. Did I say it right?
Yeah.
Yeah. But how can we get excited and all sharing that moment together?
Oh, I love getting excited about space. Okay, there's a few great websites. On New Year's Eve and New Year's Day, NASA TV, nasa.gov/ I think NASA TV or something, will be carrying live streams from APL, where I work, Johns Hopkins APL, which is running the mission for NASA. You can also go to NASA's photojournal, photojournal.jpl.nasa.gov, and you can click on, there's a little picture of a comet. It's called Small Bodies. You can click on that. You can select pictures from New Horizons, and you'll see images about as quickly as we can post them.
Oh, wow.
And that's going to be right around in a few days after New Year's Day, 2019.
Those photos on that website are amazing. Basically, any of the images you see on the show today are from that photojournal website. Really, really cool. Great stuff. And I think it's really important that we have those kind of visual assets to get people excited, because
You should bookmark that page. Just bookmark that page in your
There you go.
browser.
And just refresh.
I think it's F5.
There you
yeah,
go.
just
hit
keep
F5.
smashing it.
Yeah.
Yeah, and that's a great point you bring up, the visuals, because, I mean, as soon as we started getting those high-resolution images back from Pluto, I mean, I think everybody, it was like a ubiquitous stun. Everyone was like, because, you know, for so long we thought Pluto was this, like, lifeless kind of ball of ice, and it's like, oh no, Pluto's much more than meets the eye.
Oh, yes.
Which
It's
is-
one of the most geologically complex planets in the solar system.
And who would have thought?
Right.
Who would have thought?
Right. Yeah.
Do you have a favorite, like if you had to pick one specific point on Pluto that is your favorite, whether it's because it looks the prettiest or because it has the most interesting science or because it's something that you never would have thought existed in the solar system, what is that part of Pluto for you?
Okay, can I tell a story?
Yes,
Go
This
please.
is
for
fun.
it.
Okay, so
That's why we're here.
during the New Horizons flyby in mid-July of 2015, I was on the team. I was in the geology mission control room, and people are downloading the pictures as they're coming back. So it was like a day after closest approach. There were 3 high-resolution pictures we were going to get down first, not just of the entire planet, but of little areas really zoomed in. Okay. The first one of those that came back was of Sputnik Planitia, this nitrogen ice glacier. And there's no craters on it. You see these weird, like, kind of curvy lines through there.
Yeah, exactly.
Yeah. And people were staring at this one guy's computer monitor of that. And then there was this FTP server that I was rsyncing into, and I was downloading the second picture that was coming back, and no one else was doing that. I was the only one doing that at that point. And it was half downloaded from 3 billion miles away. So there's a black bar at the bottom. But the part that wasn't black was of the Tensing Montes.
Oh.
And everyone else wasn't looking at that. They were looking at this other guy's picture. And I'm like, hey, guys, there's mountains on Pluto. And
They're like, what?
no one heard me at first because they were worried about the glacier or whatever, you know.
Yeah.
I'm like, guys, there's mountains on Pluto. As far as I know, I'm the first person to discover mountains on Pluto.
Wow.
Just a fun story, you know. And so
Just throwing it out there.
yeah. So the Tensing Montes, which is on the southern part of the heart right there, just north of the Wright Mons cryovolcano, I think that's kind of my favorite area of Pluto because I was the first one to see it.
Aww.
Wait, you said cryovolcano.
Cryovolcano.
Can't just let that slip out.
Cryovolcano.
Thanks for asking. A cryovolcano, it's a cold volcano. So instead of erupting molten rock, the volcano, we think, if it actually is a volcano, would erupt molten ice,
Oh.
aka water. Yes.
Like liquid water,
Yeah.
I mean, yeah.
But with a twist, because it has a lot of impurities in it, like ammonia, NH3.
Oh, okay.
Ammonia, methane to the extent that you can dissolve that. And that much ammonia dissolved in there could lower the freezing point by about 100 degrees Celsius.
Oh, okay.
So you could actually erupt liquid water mixed with ammonia,
Exactly.
let it
Windex,
flow. Windex. It's like my Big Fat Greek wedding. Put some Windex on it. And it would kind of flow, and it kind of flows down, and it forms like this nice edifice,
Yeah.
a shield volcano, like just like Olympus Mons. Or sorry, not well. Yes, like Olympus Mons on Mars, or like Mauna Kea or Mauna Loa in Hawaii. But instead of being made out of the rock basalt, it's made out of the rock ice.
Oh my god.
So we think there's another cryovolcano that we only have seen in twilight images. So the planet's atmosphere actually scatters sunlight, so you could actually see in the darkness a little bit. And just south of Wright Mons, named after the Wright brothers,
Oh,
there's Picard Mons.
of course.
Yes, and Star Trek: The Next Generation is my Star Trek, and so it's Picard Mons.
You can have it.
Yes, it's actually it's not Jean-Luc Picard because it's spelled with 2 C's, but it's still Picard
Close
Mons.
enough.
Yeah, close
Yeah.
enough. And so there's another cryovolcano that we've only seen in twilight on Pluto. Oh, man. And
That
those
is
twilight
really
pictures are really
interesting.
pretty. Yeah.
So there was a question, and you know what? It's kind of farther back in the chat. I believe we had highlighted it, but this actually goes along with it pretty well. Raj Luthar had asked, do you know or have some idea of what is in the interior of Pluto? Because if we're having this level of activity, then do we have an idea of what's going on underground?
We have some inferences.
Yeah.
Pluto and all the planets are about 4.5 billion years old. We have some ideas about how planets form, and as you move further from the sun, you run out of heavy things like metal to make planets out of. So like Mercury is mostly iron core with a little bit of rocky crust on the outside.
Yeah.
As you move further from the sun, small planets like Pluto, you mostly have things we think of as gases frozen out as ices to make those planets. And so instead of having like metallic cores, we think they're more rocky cores because rock is less dense than metal. So we suspect that Pluto has a rocky core. It may have like an ocean of liquid water around that rocky core, or it may have had in the past and has since frozen. Actually, my planetary geophysics colleagues, they're like right on the fence. Like, does Pluto still have liquid water in its interior? It's like it could go either way. We don't know. We don't have enough data to know right now.
What do we need to send? What kind of instruments do we need to send to confirm that?
So InSight just landed on Mars.
That's what I was
would
thinking.
have to do the Pluto version of InSight. Land some seismometers on Pluto.
That'd be difficult though, because wouldn't there be like a level of like just like really intense permafrost? Because like you said, like things are so cold out there that like water ice acts like rock almost. So it'd need to be pretty heavy duty, right?
Sure, to survive those temperatures and to it'd have to be heavy duty. And you'd ideally have several of them. But you could also track the radio beacons coming out of those stationary landers, and by very precisely tracking how Pluto rotates, you can kind of tell what's in the middle. It's like taking a raw egg and a hard-boiled egg and spinning them.
it.
Yeah.
Okay.
Yeah, and if you stop them, the raw egg will keep spinning because the yolk and the white are still spinning on the inside.
Momentum.
But the hard-boiled egg, they're solid, and so they're not still spinning. So you can, and actually InSight's doing that for Mars. By tracking very precisely how a planet spins, you can infer what's on the inside. Isn't that cool?
My language.
That
that's
is
absolutely
Now,
wonderful.
I study surface rocks. I just study the pictures of what's on the surface.
Yeah.
People who are better at mathing do the geophysics on the inside.
Got it.
There's another question here from Heat Shield on YouTube. They want to know a little bit about the how we work out what chemicals are actually there. They asked, it'd be cool if we had mini sats like firing down at the surface with imaging and chemical analysis data sent back before they crash. Kind of like there was the L-Cross mission that crashed in the moon. They had to look at everything that was kicked up from that impact, and we're able to kind of see what it's made of. So could we do that at Pluto, and how do we work out what chemicals are there?
Well, you can do anything with more money, so sure. But what we have from New Horizons is the LISA spectrometer. We also have another camera called Ralph. It's not an acronym; it's just named Ralph, and it can image in blue light, red light, and two wavelengths of infrared light. And one of those is centered on where methane absorbs, and so you can kind of map the distribution of methane on Pluto and Charon, because Charon is Pluto's big satellite planet. They're like two planets orbiting each other, and so between Lisa and Ralph, you can look at the spectra of what's on the surface and get an idea of what's there. But with I love the CubeSat idea. I love crashing into the Pluto or landing and doing like mass spectrometry, where you can actually like take the stuff itself and you like rotate it in a magnetic field and look at its mass and charge. You can tell what it's made out of better that way. That'd be super cool.
Definitely.
Just more money.
I feel like we need to make this happen. I feel like you're really selling this, and if anyone here is watching that has, the monetary value or even the lobbying power to kind of get, if we make a big deal out of this, so we want to go back to Pluto, want to keep exploring it, we have the power to make this happen. So show your support in the comments below, or by tweeting at people at NASA and people that have the power to make this happen.
So I don't have to convince you that I love Pluto, but there's more than 120 other Pluto-sized planets out there beyond Pluto.
Yes.
They're all roughly the same size. I mean, they're all a little bit smaller than Pluto, but in that ballpark, there's over 120 other planets roughly the same size in just our own solar system. I'm not talking about exoplanets. Those are in the hundreds that we've already discovered with missions like Kepler and other detection techniques. But just in our solar system, there are over 120, probably closer to 300 small planets out there beyond Pluto. So, as geologically diverse as Pluto is, think about how much other geologic diversity and how many weird new worlds there are to discover that we need to send spacecraft to. Because with telescopes, they're just points of light. And we can tell a little bit of what they're made out of and what their spin is and a little bit of what their mass is, as if they have a moon. Using Newton's law of universal gravitation, we can figure out their mass. But to really see it up close and to get a sense of what these planets are like as places where we could envision ourselves or our robotic emissaries, we
Absolutely.
need to send more missions. We've got more than 120 to choose from. So
Yeah, and
it's-
so I'm sorry. Go ahead.
No,
No, I was just gonna say. So yeah, and looking into the future then and exploring more of these worlds. After Ultima Thule, is New Horizons? Is there more prospective targets after that one?
that's a great question. So New Horizons probably will not encounter up close another Kuiper Belt object beyond Ultima Thule. The trajectory is such that it really can't be changed that much. We're running low on gas,
Got it.
which is called hydrazine.
Yeah.
And
Nasty stuff.
yeah, well, it's great for spacecraft. It's very healthy for spacecraft, very bad for you. Don't drink it.
Got it.
But what New Horizons is going to do, pending NASA support, is to do distant observations of other Kuiper Belt objects using the really high-power zoom camera called LORRI. And from Earth's perspective, from our telescopes, including the Hubble Space Telescope, we can only see Kuiper Belt objects basically from the perspective that the sun sees them. But with the spacecraft out in the Kuiper Belt, you can look kind of sideways. You can get different what are called photometric measurements. You can get different solar phase angles, different sun object spacecraft angles, and you can learn a lot just by seeing how they rotate and getting what's called their light curve.
Nice.
So we hope to do more of that with the spacecraft after the Ultima Thule encounter. And also, it's going to take about 2 years to get the data, all the data back. You just did a Spock eyebrow. That was cool.
Oh, sorry. Yeah.
One eyebrow.
I always
Yeah.
call it my Jack Black eyebrow, but
All right.
that's cool too.
Yeah. So it's going to take almost 2 years transmitting at like maybe a kilobit per second. So like forget 1990s modem speed. This is slower.
Even more vintage. I like the
Yes.
throwback.
Yes.
Very cool.
So it's going to take a long time to get all the data back, but this mission has plenty of time.
You just completely sold this mission to me. Like, I was always excited about New Horizons because it was going to Pluto, it was going somewhere we'd never been. But the amount of excitement that you show for it and the amount of science and new knowledge we got back from it has just been so incredible. And yet, recently, Pluto kind of got demoted. We have a question from Ticklestuff here, and it's the question we asked at the beginning of the show. I want to loop us back there. Did the IAU get it wrong when they worked to demote Pluto as a planet? And does the definition of a planet matter if we're still getting excited about it?
I love this topic. Okay, so the IAU, the International Astronomical Union, henceforth just the IAU, on August 24th, 2006, they voted to classify Pluto as a dwarf planet. And I actually completely agree with that, because dwarf just means little. And
Yeah.
Pluto's little. It's a little planet. I'm fine with that. What I really disagree with are two things. The way they did it, and also their nonsensical, contradictory statement that, and they literally say this, that dwarf planets are not planets. They say that. No, of course dwarf planets are planets.
Right?
Okay, let's take inventory of the solar system here. Okay, starting outward from the sun, we have terrestrial planets. These are rocky and metallic planets. Mercury, Venus, Earth. I'm going to include the moon here for that because it's a small planet orbiting a big planet. It's a round, rocky, metallic world. Mars and maybe even Ceres in the asteroid belt could be considered a terrestrial planet. Okay, that just means rocky. We've got 4 giant planets that are further subdivided into ice giants, Uranus and Neptune, and gas giant planets, Jupiter and Saturn. Okay, we're putting an adjective in front of a noun. We're saying what kind of planet it is.
Exactly.
And then we've got small planets that I'm just going to kind of make up my own definition. Feel free to disagree, but anything smaller than Mercury, I'm just going to call it a dwarf planet.
Okay.
Just because they're small.
So now we're just describing it based on size rather than composition.
Or where it orbits, right. So I'm using a more geological or geophysical definition
Which
of a
makes
planet.
sense.
I'm a geologist.
I mean,
yeah.
I get the bias.
Thank you.
Yeah,
Thank you.
Absolutely.
And so I have no problem with Pluto being a dwarf planet. Where I disagree with the IAU is that dwarf planets are planets too.
Got it.
So kind of my mantra is ignore the IAU, dwarf planets are planets too. And that brings me to my second point of how they went about doing this. The scientific process of categorizing things in nature is called taxonomy. We're more accustomed to biologists doing this with organisms.
Exactly.
But the same thing happens in geology when you classify a mineral or a rock, or in planetary geology where you classify comet, asteroid, planet. In astronomy, is it are brown dwarfs, are they stars or are they just brown dwarfs? Neutron stars, black holes. This is taxonomy where you classify things, and it's useful for not just communication, but also because words have a really intrinsic power to sculpt our perception of reality. In some sense, words almost define reality for us, depending how philosophical you want to get. And so when the IAU, which had very few expert planetary scientists, much less planetary geologists, working on this definition, when they voted on that, in science you don't vote. Science is not a democracy. Science is driven by data, by empirical evidence, okay? And
Preach.
the way that objects in science receive their definition, like the definition of the rock basalt, which is what Hawaii and Iceland are made out of, no one voted on that definition, and yet nobody's confused, no geologist is confused when you say basalt. Because the way scientists communicate with each other through our peer-reviewed papers that we write and we publish in journals, and other scientists read them, and then we give talks at conferences and on shows like Tomorrow, and the precedent we set, it's all based on how the word is used in context that forms definitions. And that's how science is done. The IAU did profound damage to the public perception of science by making it look like science is achieved by voting and by trying to force a consensus where none really exists. And to be perfectly honest, a lot of my colleagues both agree and disagree with me on the definition of a planet, and that's okay.
Yeah.
Science progresses when we disagree with each other.
Exactly. Yeah.
And that forces us to really dive in deep and to understand what it is that we're studying, to understand our discipline better. And so the IAU gave a false perception of consensus where none really exists, and they tried to force it with a vote. It's a huge, profound misuse of of what they do. And so I simply ignore the IAU definition. I just don't use it.
Go
And
against the man.
Many planetary, or woman, but
Woman.
yes, go against the human.
There you go.
Many planetary scientists just ignore it. So if you actually look through the papers that scientists write, these peer-reviewed journal articles, both before and after the IAU definitional vote, we use the word planet to refer to things like Titan or Pluto or our own moon or, I don't know, Europa, Enceladus. You'll see, instead of saying the name of like Titan over and over again, Titan has sand dunes, Titan has an atmosphere, you start saying Titan has sand dunes, and the atmosphere of the planet is made out of nitrogen and methane. So the word planet starts substituting for the name of the object we're studying. And if you look at that precedent, and lawyers know all about precedent, that's how legal cases get decided, is the precedents. And if you look at the precedent in the literature, the word planet continues to be used for things like Pluto.
I think you raised a really good point here, which was that the way we use our words and the way it's used in context and its common usage is kind of where our definitions come from. And one thing the IAU didn't do is they didn't speak to anyone in the public about what they were doing. And like you said, it made a really bad public perception because no one included the public on this. Like for me, growing up, Pluto was always a planet for me. It's what I learned in school, and it's what, if I go to my parents and I talk to them about planets, they're going to include Pluto in that because that's the common usage that the word has had, to refer to Pluto. And so I guess what you guys are doing by continuing to use the word planet when referring to Pluto and these other bodies will help add to that credibility of we can make that word fit to how it's actually used, not by just some vote that we have.
Exactly, yeah.
With some elite group in their meeting room.
We don't vote on if climate change is real.
Hey-o.
We don't vote on the taxonomy. We shouldn't vote on the taxonomy of things. We should just see how scientists use the word. And if Pluto's a planet, we also have to be comfortable with there being over 120 other similarly sized planets.
Exactly.
And that's okay. It's more than a fourth grader can memorize, and that's okay. We need to change how we teach the solar system. Okay. Instead of learning a list of names of planets, don't do that. Learn kind of the zones and the organization of the solar system. You could see where there's maybe between 3 to 6 zones of the solar system. We've got this inner solar system of rocky planets, asteroid belt, giant planets in kind of this middle zone, and then we've got the Kuiper Belt, the swarm of planets, of dwarf planets and smaller worlds. It's dwarf planets and smaller worlds out in the Kuiper Belt.
That's so fascinating,
and if you absolutely have to memorize a list of names, pick the top 20. I don't know.
There you go, yeah. So Jared, you met earlier, who was on the space show. So him and I work at Griffith Observatory, and we have this really great school program we do for 5th graders. And I love that you mentioned teach them in zones, teach more of the classifications versus like the actual Mars, Mercury, you know, and so
Right.
on and so forth. And that's kind of what we try to do is like, yeah, we list the names of the traditional, if you want to call them that, planets, but then we describe, as you just did so eloquently, yeah, like these are terrestrial, this is why, these are gassy, this is why. But yeah, that's kind of like a whole like almost pedagogical
Yeah.
shift. Yeah.
Googly.
The googly, yeah. Good one. Yeah, so this is really like, I mean, I don't know what the viewers are thinking out there. I mean, I came into this interview thinking, yeah, we're going to talk about like planets. Oh, is Pluto a planet? You know, it was kind of, it's a big point in kind of like pop science.
Yeah.
But this is actually a very deep philosophical kind of re-examination of, you know, of science and of interpretation. And so, yeah, I just thought I'd make a comment about that because I'm really into it.
Cool.
So
Yeah.
thank you for
shift.
bringing that insight.
Sure.
Definite shift in the way we approach education and science education. It's no longer about memorization and rote learning. It's about learning through experience and changing that perception. You know, like instead of just memorizing 9 planets, if we learn that there's, you know, over 100 planet-like bodies in our solar system, then we're shifting our whole perspective on what our solar system is. We're not like this little exclusive little group with Earth at the middle. Like
Right.
we become part of our greater like galaxy and our greater universe. through
Yeah.
that.
I'm guessing someone's going to ask, so how do we make Pluto a planet again? I'm guessing that's going to be a question out there. The point is that Pluto never stopped being a planet if you simply just ignore the IAU. Because many of us expert planetary geologists, and I say that in a humble way, like I do this for my profession,
Yeah.
many of us just don't use the IAU definition, and the general
it.
public can be free to not use it as well. So Pluto never stopped being a planet, and it brought over 120 of its friends with it into planethood.
Nice.
So-
It led the charge.
Yeah.
On that, if there are people that want to get more involved with your work and what you do, what's the best way that they can keep up to date with you?
Probably my Twitter, which is NASAman58.
Nice.
Yeah, so NASAMAN 58. The 58 is the year NASA was created. So
Clever.
Yeah. See what I did there? So I post periodically on there about the work I'm involved with. So
Wonderful.
it's probably the best way.
Cool.
I guess I'm not hip enough to be on Instagram. It's just Twitter.
Well,
Hey, Twitter is fine.
Twitter's pretty lit right now.
Yeah,
Kids
okay.
still say lit. Yeah.
I mean,
there
I
you
don't
go.
know.
I mean, I don't know.
If you know what's in, let us know. Cool. On that note, I really want to say a huge thank you for your time. This has been an incredible interview and an incredible way to wrap up the year. I don't know about you guys, but like I'm so like pro Pluto and pro like sending like a lander or an orbiter mission there. And just I need it on a shirt now. I'm just a big fan. Yeah, thank you so much.
My pleasure.
Before we do go to break, we want to give a huge thank you to our supporters of the show, our citizens of tomorrow, specifically our Escape Velocity citizens. These people contribute $10 or more per episode to the show, and we couldn't do this without you. But we also have our Orbital subscribers as well, and these people contribute $5 per episode. And honestly, we couldn't do amazing shows like this, talking amazing science and getting you guys excited about the science behind these missions that we're sending out into the solar system without your help. We get to have amazing guests like Kirby coming on the show thanks to you. And next year is going to be even bigger and even better. Your contributions directly help us, and by next year we may even be able to get science down to once every 2 weeks, maybe even once a week. So if you'd like to help out, go and head over to patreon.com/TMRO. We're going to take a quick break, and when we come back, your questions and comments featured. Stay tuned, we'll be right back.
We've always looked to the stars. They guide us, give us comfort, help us find our way. We see ourselves out there. When we look up, it inspires us. And we long for something we don't yet know. We yearn to go there. So, we venture forth.
We choose to go to the moon in this decade and do the other thing, not because they are easy, but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills.
Tranquility Base here. The Eagle has landed. It's one small step for man, one giant leap for mankind.
The exploration of space will go ahead. whether we join in it or not.
Many think we stopped exploring. But we know our journey didn't end. We've only just begun.
Orion is functioning perfectly at this point.
Come with us and explore tomorrow.
Well, hello, nice to see you again. So we're going to go ahead and dive right into your comments from the last show. And last month's show, we actually got to speak with Dr. Walter Longo from the USC Longevity Institute. We talked all about how diet can lead to a longer life, aka maybe immortality? Just kidding. But nonetheless, it was a fascinating interview and we had a lot of great interaction from you folks. So going right into the comments, the first one we are going to read is from YouTube and it's from The Moon is Square. Again, one of our top favorite names of accounts here tomorrow. And the comment states, I think the ability to fast should play a critical factor in choosing the first Mars passengers, deciding between taking either two 50-kilogram people or one 100-kilogram person. Sort of self-contained food storage and a little extra organ radiation protection.
So for some context here, like last week we were talking about how if you do like fasting or fasting mimicking diets, you can like turn on and activate and increase transcription of genes that help repair DNA. And so that's kind of where this came from a little bit in terms of like, if we send a 100-kilogram person and then like they just like have the ability to fast and turn on their DNA repair, will that like help them with radiation? Like, because when you're in space, you're gonna get increased doses of radiation. So now you're like being bombarded with radiation, you're potentially damaging your DNA, but you have all this extra kilograms. So now you fast and you're okay, you're not gonna die because like you had extra kilograms on you, and now you're repairing your DNA at the same time. Like win-win.
Yeah, and
Win-win.
I never even thought to use these methods to become like super efficient humans who are someday going to travel to Mars and beyond. So I really like how the comment tied it back into like space travel, because I was like, biohacking? Okay,
Right.
got it. Interesting. So going into the next one, this is actually an image, I believe, from the community at community.tomorrow.tv. This is from astro_YYZ, and they state, here's one of M51 I took using the Twitter-activated Burke-Gaffney Observatory's robotic telescope. I usually shoot comments. And
That's beautiful.
That's very nice.
Oh, cool.
Wow.
Oh, wow.
So for those that don't know, the Burke-Gaffney Observatory, it's a telescope robot. You can command it using Twitter, Facebook messaging, or email. So you can control that over the internet, over Twitter. Kirby, I know you're a fan of Twitter.
Yeah.
Have you ever?
You could tweet at the telescope.
You can tell it what to like take pictures of. Like,
Robot telescope.
yeah.
So
Have you ever used
No,
that?
I haven't.
I want to go on there
does it
and
respond?
I don't know if it like talks back to you and says beep boop boop. I took your photo. Thank you.
It's probably really snarky.
Right?
That would
Like,
be
you
cool.
want to take a
Sarcastic.
picture of that? All right, you're the
Yeah.
boss, I guess.
But like how cool that you can control a telescope. Like that's opening the access of like science and astronomy to other people
Yes.
that maybe you don't have a telescope in your backyard, but if you have the internet and you have Twitter or email or Facebook messaging, you can go and control a telescope and take your own pictures of stuff. Like
That's a beautiful,
that's so cool.
beautiful thing.
I want to use that.
Democratization, my folks.
So once again, that's the Burke-Gaffney Observatory with its Ralph Medjuk CDK-24 telescope robot.
Wonderful.
We'll put a link in the description so like you can easily find where to control it. But that's really cool.
Very cool. And we actually have another beautiful image. This is from Harry Stranger, again from the community. And they state, I can't wait to get my rig set up and complete to shoot some deep sky objects down here. The ISS is my favorite right now. I caught this the other night. Wow.
Oh, cool. Is that the Large Magellanic Cloud just underneath it?
Potentially it is because this is taken from Australia,
man.
Southern Hemisphere,
Yes,
so you can see
it could be.
the Magellanic Clouds, which is really cool.
That's fantastic.
Do you guys like have telescopes and do that in your own backyards?
I do have a telescope. It is in need of a bit of repair, but nonetheless, yes, I once was quite active.
Kirby?
I do have a telescope. I mostly use it for the moon and planets. And actually, a lot of people think that full moon is the best time to look at the moon through a telescope. False. You know this because you're at Griffith
yeah.
Observatory.
Yeah.
Yeah, you want it like first quarter.
Yeah.
Or I really like it, but you got to get up early in the morning, like last quarter, third quarter moon. 'Cause
Exactly.
The Terminator, where like the sun,
Get to
the
the
day night.
chopper.
Yeah,
Yes.
and you can
You can see the shadows from the craters and the
Details.
central peaks.
Beautiful.
You can geologize the moon better.
geologize. Is that a word?
I
It is
love
now.
that word.
Wow.
Hey, we just
I'm
talked.
using it.
You just talked about how words meaning, like definitions, are based on how we use them. So
Exactly.
if we keep using that word,
I'm
it's
gonna
going to be a
geologize
thing.
the
become a-
heck out
I'm
of
going to
it.
geologize all the words.
That's amazing.
Geologize
Yeah,
all the words.
I feel like the way you look at the moon is kind of like a steak preference. Like people who don't know any better are like, I want it well done, like to a crisp. And it's like, well, if you have a good enough steak, you get it, rare or medium rare. And it's like same. It's like if you know how to look at the moon, you know to look at it. Not at full moon, but as
Right.
you stated, I like my moons the way I like my steaks.
Oh man, now I want steak.
Shady and cratery.
Crunchy.
Geologized.
Geologized.
I like
yeah,
my
there
moon
we go.
geologized.
All right.
On that note, though, we love featuring the science and stuff that you guys are doing at home. So if you take photos of anything in the sky, or if you're like building your own microscope, or if you've got plants in the backyard and you're doing your own little experiment on like how to grow your plants better, don't take my example because there's plants over there that are dying, but we won't talk about that. Post it in the community forums, community.tmro.tv. We want to feature them. We want to see how you're discovering the world around you. That's what we're all about. Jay, do you want to bring us out?
Yeah, sure. So, of course, we can't say goodbye until we acknowledge the folks who make this show exist, and that would be our Escape Velocity citizens. If you enjoyed any part of this interview, then you can just go ahead and thank all of these lovely folks here. They contribute $10 an episode on Patreon, but they're not the only ones. We also have the Orbital citizens who contribute $5 an episode on Patreon. And hold up, Suborbital citizens, $2.50 an episode on Patreon. And of course, we cannot forget our Ground Support citizens, which is $1 an episode on Patreon. You guys are the lifeblood of this show. You are why we wake up bright and early on Saturday mornings to get in here and speak to awesome folks like Dr. Kirby Runyon. And so if you would like to become a contributor, then go ahead and head on over to patreon.com/TMRO, or simply subscribe, share, and tell all your closest friends at the dinner table, hey, check out tomorrow. They're doing some pretty neat stuff, because that in and of itself is greatly appreciated. So on that note, thank you so much for joining us, and thank you, Dr. Runyon. We are more jazzed than ever to explore the outskirts of our solar system, and for you, we thank you. We will be back next month.
Next month.
Which is January 2019. We'll see you next year. And we will probably announce what's going on.
Ultima Thule, New Horizons.
Don't forget.
Don't forget.
End of the year. Happy
Yes.
New Year. Happy Ultima Thule New Horizons Day. Have a happy holidays and see you in January.
See you next year, folks.